Welcome. On this video, we will be reviewing the Pythagorean theorem. Okay, so let's start by just stating what the Pythagorean theorem is. Uh, by definition, in a right triangle, the square of the hypotenuse is equal to the sum of the square of the legs. And again, this Pythagorean theorem, it's only applicable whenever we have a right triangle. So if we don't have a right triangle, we cannot apply the Pythagorean theorem. This is how you might have seen it before. A squared plus b squared equals c squared. But let's see if we can use what we have discussed in the previous lesson to state that the Pythagorean theorem is true for a right triangle. But let's try to use a different approach. Let's try to use the approach for the geometric mean. So let's start by identifying two things. We're going to create two equations. One for the geometric mean of A. Okay, so let's set this up. So if A is going to be our geometric mean, that's the placeholder. But now notice that A, we want to find out the geometric mean between A. Well, on the previous lesson, we said that A is the geometric mean between the whole, which in this case is C, and the small one, which is E. Again, A is the geometric mean between the whole hypotenuse of the big triangle over the section of the hypotenuse for this triangle. Okay, so now let's write down the geometric mean for B. So for B, that's where we will replace if it's a geometric mean. But notice that B is the other side, and the other side, it's a geometric mean between the whole and the small, which in this case is D. So now that we have set this up, let's cross multiply. So if we cross multiply, we have that A squared equals CE. And if we cross multiply, we have that B squared equals CD. So if this is true, if these two statements are true, then therefore A squared plus B squared, that's equal to CE plus CD. Because A squared plus B squared, well, A squared is CE, so A squared is CE, B squared is CD, B squared is CD, so A squared plus B squared equals CE plus CD. Now notice that if we have it written down in this form, we have two terms on the right hand side. They both have a C in common, so we can definitely factor that out. But now if we go back to our triangle here, what is exactly E, line segment E plus line segment D? Well, E plus D, that's exactly the whole hypotenuse, which is C. So now we have A squared plus B squared equals C times C, which is A squared plus B squared equals C squared. So this is just a different way of showing that the Pythagorean theorem is true if we want to use geometric mean. But again, this is just a very cool way of showing that the Pythagorean theorem is true. But as long as you recall that the Pythagorean theorem is just the square of the hypotenuse, it's always equivalent to the sum of the square of the legs, aka A squared plus B squared equals C squared. And very important, this is only applicable for right triangles. Let's just review how can we apply this. Okay, so we're just going to do three quick examples. First thing that you want to do is identify if we have a right triangle, which we do. So if we have a right triangle, then we definitely can apply the Pythagorean theorem, which in this case, it will become 3 squared plus 7 squared equals x squared. Because notice that x is exactly the hypotenuse, because that's the side that is opposite of the 90-degree angle, and there's another leg, and there's another leg. So leg square plus leg square is hypotenuse square. That's what we do have here. And at this point, once that you have set it up in such a way, then we definitely just have to simplify this a little further. So 3 squared is 9, 7 squared is 49, that's x squared. So now we have that x squared is equal to 58, where x is equal to the square root of 58. Perfect. Can we still use the Pythagorean theorem whenever we don't know the actual sides of the legs? So if we do have just variables, Yeah, it's just going to be a little more complicated, but we can definitely solve for x. How will we go about it? Well, first, we can identify that we do have a right triangle because we do have a right angle. So that's great. Knowing that we have a right angle, then we can just identify what's the hypotenuse. So that's the hypotenuse. That's my leg. That's my leg. So therefore, we just apply the Pythagorean theorem, which says one of the legs square, which is just, let's just pick the one on the bottom. So this is the value of the leg. So the whole leg square plus the other leg square, which the second leg has a value of x, is equal to the hypotenuse square, which in this case the hypotenuse is 10. So notice that we do have here a not a very nice equation, but the only thing that the only variable that we do have here is 1, which is x, so definitely we can solve for it. One equation, one variable, we can definitely solve for it. So what exactly is x plus 2 squared? But that's equivalent to just x plus 2 times x plus 2. Now let me just bring down the rest of the equation. Now let me just simply, because 10 to the second, that's 100. So if we distribute this, we're going to end up with x squared plus 4x plus 4. That's equal to x squared. Let me just bring down the rest. This way, let me combine like terms. And if we combine like terms, we will see that we have x squared plus 4x plus 4 equals to 100. All right. So we definitely want to solve for x. So let's create our equation to be equivalent to 0. So let's just subtract 100. And now this becomes x squared plus 4x minus 96 equals 0. And at this case, I'm sorry, I think I did a small mistake. Yep, here. Notice that x squared plus x squared is not just x squared, but that's 2x squared. So definitely. So how can we solve for this? Well, I can see that I have a leading coefficient of 2. And also I can see that every single term can be has a factor of 2. So I can factor out a 2. And if I factor out a 2, that's going to become x squared plus 2x minus 48 equal to 0. And if we were to divide it by 2, notice that the 2 will cancel out, or it will disappear because 0 divided by 2 is 0. So that's one way that we can use to just get rid of the leading coefficient. And in this case, we think, well, the leading coefficient is 1. I can definitely solve for this. How can we solve for this? I can factor it out. So let me find two numbers that if I multiply, it gives me negative 48. And also, if I were to add them up, it gives me 2. Well, in this case, those numbers are 8 and negative 6. So I can just factor out this expression as x plus 8 times x plus 6. Because notice that 8 times negative 6, it is 48. And 8 plus negative 6, it is 2. So we're good. And now that we have it in this form, we can definitely solve for this. So we have two equations. We have negative 8 and we have positive 6. So great, we have two solutions. So that means that there's two legs, two values for the legs of this triangle. Well, not exactly, because one of the value of the legs is equivalent to x. But notice that here we're saying that x is equivalent to negative 8. And this doesn't really make sense. There is no such thing as a negative length. Here we're saying that x represents this length. And here we're saying that the length is going to be a value of negative 8. So that doesn't make a lot of sense. So therefore, negative 8 cannot be an answer. So that means that the only possible solution is just positive 6. All right, so let's take a look at example C now. Let's take a look at example C now. Let's see, how can I do this? Let me just separate this. All right, great. So here we want to solve for x, which knows that the x can be seen as kind of like the height of this triangle. And we do have, notice that this is the same situation. No, I'm sorry, this is not the same situation. Well, notice that the only thing that we do have here is that we have two similar right triangles. But let's stop here for a second, because if they are similar, then it must be in proportion. So therefore, if this side is 5, we can see, I mean, hold on, let me pause here for a second. Let me use some colors to differentiate here. So if I'm claiming that these two triangles are going to be similar, because they're both right triangles, we can see that these two sides are corresponding sides, and they happen to be the same value. So that means that the ratios are going to be of a value of 1. So that means that every single ratio, so 5 over 5, it should be equivalent to 1. That means that if these two corresponding sides have a same value, then therefore every single corresponding sides must be of the same value. So let's think about that for a second. So we can kind of see that this leg is going to be corresponding to this leg if we separate these two triangles. So if we separate this triangle and we separate this triangle, this side is corresponding to this side and this side is corresponding to this side. But I already know that the ratio must be of a value of 1. So therefore, if I divide this side and if I divide this side by this side, they must be of a value of 1. But if I know that the whole length is 8, so therefore, each side must be of a value of 4. Because in order for us to say that they have similar right triangles, all ratios must be true. So definitely 4 over 4 still gives me the same ratio as I did with the other corresponding sides. And again, this is only true if we've been given two corresponding sides with the same value. So therefore, all sides must be of the same corresponding value. And once that we set it up this way, then we're pretty much good to go. So how can we solve for x? Well, let's just separate this. I'm just going to concentrate one of the triangles because there's no need for me to concentrate the whole thing. So if this is 5, and now we know that this is 4, this is x. So I'm just separated this triangle, and I put it over here. That's a right triangle because that's what we've been given. That's a right triangle. Therefore, we can use the Pythagorean theorem. So now this is going to look 4 squared plus x squared is 5 squared. And let's just simplify this. 4 squared is 16, x squared 25. If we subtract 16 on both sides, now we're going to end up that x squared is equals to 9, and therefore if I take the square root, so x is equals to plus or minus 3. But again, it doesn't make a lot of sense for me to say that this length has a negative 3. So because of that, I'm only going to just take the positive value, which is just positive 3. All right, I hope that this is helpful, and this was just a small review for the Pythagorean theorem.